Hi. So when we are working with a normal distribution or we're working with standardized scores or z-scores, and we have word problems like this, it's always important to underline the important elements of what we're going to take away from it. So in this particular word problem, we have the population mean of 128. We have the population standard deviation of 23. We are assuming that there's a normal distribution, which is good. That means that we will be using a z-score. And then it says the probability that a randomly selected person has a blood pressure of 88.3 or more. That or more is the key component to write out our givens. So we will be looking for the probability of X being greater than 88.3. Now, because under a standard distribution curve, it's always worth 1. So when we are looking at a z-table chart, it is actually going to give us the area to the left, which is the number less than that. So because that's not what we're looking for, all we would have to do is take 1 from the probability of X being less than 88.3. My next step for you is to draw it out. So again, so the mean is 128, and the z-table chart is always going to give us the area to the left. So I just write a little g here, just so we know that it's the area to the left. Now, based on the prompt, it says we need X to be greater than 88.3. That means that we're going to need the area to the right. So that means when we go to the z-table chart, we are not done. We're going to have to subtract our answer from 1. Okay? Third step would be to actually calculate the z-score. If you recall, the formula for a z-score is the sample mean minus the population mean minus the population standard deviation. So based on our givens, we just kind of plug in from the formula and we do 88.3 minus 128 divided by 23. That gives us an answer of negative 1.7261, which with z-table chart, we're going to pretty much guesstimate this to be and round it to negative 1.73. Now, if we go to the z-table chart, we end up seeing that negative 1.73. Going to a z-table chart is similar to like going to a football game. We have our section, which would be the negative number. So that negative 1. Then we have our row, which is that negative 1.7. And then we find our seat, which is 0.03. So here, 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 and then our seat is here at 0.0418. Okay, so we're going to go back to thing. And so we found that the probability of a z-score being less than negative 1.73 is 0.0418. Now, we said earlier, based on our drawing, we're not done. So we would have to do 1 minus that probability of z being less than negative 1.73, which gives us an answer of 0.9582. Okay. For question C, we're essentially doing the same thing. So we already have our givens of the 128, the population standard deviation of 23. We know that it's normally distributed. This time it's saying that, find the probability of 174.9 or less. That or less is important because that means that all we're doing is getting the area to the left. So again, when we go to a z-table chart, that means that it's going to give us the area to the left. So we can just shade in this area here and put a little g here. Now, based on the prompt, we also need the area less than 174.9. So that means that we can shade in this area as well. Hopefully better than how I'm drawing it now. And put it in here for needed. So what's given and what's needed are in the same area. That means that when we get our answer, we're going to be done. So then we're going to calculate the z-score. Again, z-score formula is sample mean minus population mean minus the population standard deviation. So we're going to plug in our answers here and do 174.9 minus 128 divided by 23. That gives us an answer of 2.0391. We round that That gives us a score of z-score of 2.04. If we share the screen, we can see that 2.04, again, our section is positive. And so 2.0 is our row, and then we see 0.9793. Okay. So that means we're done based on our drawing. So the probability of getting a score that is less than 174.9 would be the equivalent of 0.9793. Okay. Similar in this instance, the only difference is that we're looking for the area between. So again, we have all of our givens. The only difference is we're trying to find the area between 174.9 and 88.3. So again, if we go through our givens, that means that we want for 94 or 174.9 the area here, and then we also want the area minus the 88.3. Now, based on our prompt, we want the area in between. So that means we're going to draw this much more prettier than mine, and we're going to put it in right here. Okay, which means we're going to need to separate the part here out of less than 88.3. Okay, we already calculated the z-score previously, so we don't have to do this now. So I just went ahead and put it back up here. But for finding the probability, we need to find x, the area between 174.9 and 88.3. So that's giving the probability of that minus the probability of going to 88.3, which again, all we're essentially doing is finding the area that was for 174.9 and subtracting from the area that was for 88.3. So if you recall, the area for that negative 1.73, which was for 88.3, was 0.0418. And if you remember from the previous question, for 174.9, the area for that was 0.9793. So all we would do is take 0.9793 minus 0.0418, and that would give us our answer of 0.9375. Okay. For question E, essentially the same. We have our important values, which would be population mean of 128, population standard deviation of 23. We are assuming that it is normally distributed. And we're pretty much writing everything out. And then we're also trying to look for the probability of having blood pressure that is at most 70.5. That term at most means that that's the highest amount, which essentially means we're finding the probability of X being less than 70.5. So if we were to draw it, again, the z-table chart is going to give us the area to the left. So we're going to put that here, and we're going to draw it and put a G right there. Then the area to the right would be, because it's just less than, it's still in this little hub here. So we're going to put it in there. That means when we get this score, we are done. We're not going to have to do anything else after that. So calculate, we're going to plug it into the formula. And again, the formula for Z is sample mean minus population mean divided by population standard deviation. So that would be 70.5 minus 128 divided by 23. That gives us a score of negative 2.5 for our z-score. So we're going to just mosey on over to the z-table chart and find that negative 2.5. So if we go to negative 2.5, again, our section is that negative. Our row is negative 2.5. And then our seat would be that 0.00. So that gives us a score of 0.0062. Okay. So the probability of us having an X that or blood pressure that is at most 70.5 is at or around 0.0062. Okay. For question F, it's essentially, we have the same information that we had from the previous problem. So we have our given, the population mean, population standard deviation. It says there's a blood pressure 70.5 unusually low. So a rule of thumb for something that is unusually low is something that is less than 0.05. So if you recall, the probability of having a score less than 70.5 was equal to 0.0062. That 0.0062 is less than 0.05, which means yes, the event is unusually low. So what we need to do is we need to go through each word problem or each answer choice and just kind of see. So because we said yes, the event is unusually low, that automatically means we can get rid of all the no's. Process of elimination. Get rid of the no's. Okay. No, 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 no. All right. So now we're just left with the yeses. So it's the first one says yes, since the probability of having a value of blood pressure at least that high is less than or equal to 0.5. So the term at least that high means that 70.5 is the highest, it's the lowest value. And if you recall, we were looking at pretty much that number below. So that would knock this out because of that. The next one says yes, since the probability of having a value of blood pressure at the most, that value is less than or equal to 0.05. Well, that's exactly what we just said. Because the value was less than 0.05, yes, the answer is yes, it is unusually low. So we're going to table this. We're not going to mark it out just yet because we want to look at everything. The next one says yes, since the probability of having a value of blood pressure at least that high is greater than 0.05. So at least, again, the term at least means that is the absolute smallest value. So it'll be 70.5 and up, which that would make it a lot more than 0.0062, right? So because of that, this is incorrect. Lastly, yes, since the probability of having a value of blood pressure at most, that value is greater than 0.05. We've already established that it is not greater than 0.05. It is less than 0.05. Due to that, this answer is incorrect, which means the only answer that it could be is yes. Since the probability of having a value of blood pressure at most, that value is less than or equal to 0.05. Okay, question G. Again, we have the exact same prompt for our information. We have our population mean here. We have our population standard deviation of 23. We're assuming a normal distribution. And then it says, what blood pressure do 50%, 57% of all people in China have less than? So that term is important. So essentially, we're working backwards. They give us the probability value, and we are expected to work backwards. So my recommendation would be to write out your givens as usual. X less than Z is going to be equal to 0.5700 or 0.57. It says round your answer to 2 decimal places. So I always recommend going to the formula due to that. So if we go to the Z table chart, it would be important to do one of two things. You can either go to Excel and work it out that way, or you can go to the Z table chart and find 0.57. So if we look here, 0.57 would roughly be here. It would roughly be in this little area here. So the way we would do this is we would do that 0.17 and then that 0.178, we would add those and average it out. If we were to do that, that puts us at about 0.175. If you put it in Excel and do the inverse, so norm inverse, and put in these numbers, it will give you 0.176. So we're going to operate off that 0.176. And now we have our formula, but we also have what our Z-score is. Okay. So now we have the z-score, and we already have the population mean, we have the population standard deviation, and we have the z-score. We just don't have x. So now we would need to solve for x. So we have it set up here. We have x minus 128 divided by 23 equals 0.176. Again, getting x by itself, so we move the 23 over. That would give us about 4.048. So now we have x minus 128 equals 4.048. And then we would move that 128 over, which would give us about 132.048. Now, it did say to round your answer to 2 decimal places. So that would kind of round it out to 132.05. Okay, hopefully that helps. If anybody has any questions, let me know.